by a distance of 0.5 meter. So this is the magnitude of the force and the direction on the charge at C. I have to calculate the charge on each ion. Turns out to be 1.48. What is the resultant force? Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. A new topic, a new session. Today I will be solving problems from the chapter Electric Fields and Charges. And basically, the concept that I will consider today will be Coulomb's law and its applications. So, we will work out problems based on Coulomb's law and its applications in today's class. The first one. The problem says 2-point charges, each of 0.65 microcoulomb, are separated by a distance of 0.5 meter. There are 2-point charges, each of magnitude 0.65 microcoulomb. So Q1 is 0.65 micro, which is 10 power minus 6 coulomb. Q2 again 0.65 into 10 power minus 6 coulomb. And they are separated by a distance of 0.5 meter. So distance of separation is 0.5 meter. The first part of the problem is to calculate the force of repulsion. Either it be force of repulsion or force of attraction between any two charges separated by some distance. How do I calculate it? Our very famous Coulomb's law. So here, Coulomb's law says F equals 1 by 4 pi epsilon naught Q1 Q2 by R square. And the moment I write epsilon naught, it very clearly means the two charges are placed in air medium. So this is F equals 9 into 10 power 9. The value of 1 by 4 pi epsilon naught is 9 into 10 power 9 into 0.65 into 10 power minus 6 into 0.65 into 10 power minus 6. Q1 and Q2 have the same magnitude. divided by 0.5 whole square, and on simplification it turns out to be 1.5 into 10 power minus 2 Newton. So in the first case, I have calculated the force of repulsion. The second case, what is the force of repulsion if each charge is doubled? Now, each charge is doubled and the distance between them is reduced to half. Now, each charge is doubled and the distance between them is reduced to half. In this case, again, F is the same formula. Now, each charge is doubled. So, this is 2 into 0.65 into 10 power minus 6. 2 into 0.65 into 10 power minus 6. And the distance between them is reduced to half. So 0.5 by 2 whole square. Again, when you simplify here, so it is 0.243 Newton. So this is the magnitude of the force when each charge is doubled and the distance is reduced to half. And finally, force of repulsion if the two charges are placed in water. Now the two charges are placed in a material medium, water, whose dielectric constant epsilon r is given to be 80. So remember, so in this case, the new force will be F divided by epsilon r. F is 1.5 into 10 power minus 2. Epsilon r is 80. So in this case, it is 1.9 into 10 power minus 4 Newton. So see, just very basic application of Coulomb's law. The next one. Now he says, the electrostatic force, between two like ions, same ions, separated by so much of distance, 5 into 10 power minus 10 meter is 3.7 into 10 power minus Newton. What is the charge on each ion? Charge on each ion. And how many electrons are missing from each ion? Electrostatic force between two like ions, which means let Q1 be equal to Q2 be equal to Q. They are like ions. How much is the electrostatic force? It is 3.7 into 10 power minus 9 Newton. And the distance of separation 5 into 10 power minus 10 meter. I have to calculate the charge on each ion. Coulomb's law. Mr. Coulomb is there for our help wherever it is attraction or repulsion between charges. So we have F is 1 by 4 pi epsilon naught Q1 Q2 by R square. How much is F given to be, students? 3.7 into 10 power minus 9. So 3.7 into 10 power minus 9. Again 9 into 10 power 9. Q1 is Q, Q2 is Q, distance of separation 5 into 10 power minus 10 whole square, or 3.7 minus 9, 9 into 10 power 9 into Q square divided by 25. Now, so when we simplify here, Q turns out to be minus 19 Coulomb. So Q1 and Q2, since they are like ions, they will have the same magnitude. Now, how many ions are missing? See, charge of the electron is 1.6 into 10 power minus 19 Coulomb. If you observe, this is twice that. So, number of ions missing is nothing but equal to 2. Next one. Find the separation between two protons. So R has to be calculated. The separation between two protons, in order that the electrostatic repulsive force acting on either of them may be equal to its weight. So the condition given is the electrostatic force between two protons is equal to the weight of the proton. Under this condition, I have been asked to find the separation between the protons. Charge of each proton is plus 1.6 into 10 power minus 19 Coulomb. Mass is 1.67 into 10 power minus 27 kg. G is 9.8 meter per second square. Now, what is the given condition? electrostatic repulsive force is equal to the weight of each proton. Clear ಆಗಿ ಹೇಳಿದ್ದಾರೆ. Electrostatic repulsive force is equal to weight of each proton. What is the electrostatic repulsive force? Coulomb's law. Good. 1 by 4 pi epsilon naught Q1 Q2 by R square. Weight is nothing but m into g, mass into gravity. Again, 1 by 4 pi epsilon naught, 9 into 10 power 9, 1.6 into 10 power minus 19, 1.6 into 10 power minus 19 divided by R square. R square has to be calculated. Mass of each proton 1.66 into 10 power minus 27, 9.8, where R square turns out to be 1.48 or R turns out to be 0.119 meter. Again, it is simply equating electrostatic force with the weight of the proton, getting the relevant expressions, simplification and answers. The next one, students. This is important. Point charges -9 microcoulomb, -20 microcoulomb and +10 microcoulomb are placed at the corners A, B and C respectively. I introduce a word here, right angled triangle ABC. Now, I assume I have a right angled triangle ABC, where C is the right angle. At A, there is a charge of -9 microcoulomb. At B, -20 microcoulomb. At C, +10 microcoulomb. Now, AB is 0.05 meter. BC is 0.04 meter. And CA is 0.03 meter. Calculate the resultant force and the direction on the charge at C. The magnitude of the resultant force and the direction at the charge at C. Now, first I will calculate force on the charge at C due to the charge at A. I call that F1 1 by 4 pi epsilon naught. Charge at A is Q1. Charge at C is Q3. Distance is CA whole square. Or F1 9 into 10 power 9 into. If you observe Q1, there is something important. Minus 9 microcoulomb. Please do keep in mind, wherever you calculate force and intensity, don't consider the negative sign. Intensity is also a type of force. Negative sign only shows it is repulsion. Wherever you calculate potential, calculate or use the negative sign. So this is 9 into 10 power minus 6 into, again 10 plus 10 minus 6 divided by, the distance is 0.03 whole square, or F1 is, on simplification, it is 900 Newton. What is the direction? Properties of electric lines of force always starts from the positive charge, ends on the negative charge. At A there is a negative charge, at B, C positive charge. So this is the direction of F1. Now similarly, force on the charge at C due to the charge at B. F2, same formula. So now Q1 again is 20, no negative sign. Distance is 0.04. So this we wrote, direction is along CA. So again, when you simplify, this is 1125 Newton. Again, what is the direction here? Positive to negative along CB. Now, what is the resultant force? We have studied that. Root of F1 square plus 2 F1 F2 cos theta. What is theta here? 90 degrees. Which means cos 90 is 0. So this is root of 900 square to 5 square. So on simplification, this is 1141 Newton. So I have calculated the resultant force. Direction of the resultant force, alpha is tan inverse F2 by F1. Substitute 51 degrees, 20 minutes will be the answer. Again, the problem appears tedious, but step-to-step simplification, very easily you can get the answers. In my next session, I'll work out few more problems from this chapter. Until then, have a nice time. Thank you.